total equal to 210, course schedule 2. And for every for this question, it give us two-dimensional array prerequisites and also number of courses. And let's return the order we can take for these courses. So just say that if there are multiple answers, you can return any of them. And if possible, if it's not possible to finish all the courses, return empty array. Right. So comparing to the question 1, the difference is that we need to get one of the solution. So we know they may have multiple solutions. For example, A goes to C, B goes to C, right? So let's say A, B, C is a valid answer. B, A, C is also a valid answer, right? So the same thing as course schedule 1, right? We need to compose the map, compose in degree, and also we use a queue, right? We use a queue for every in degree with 0, because that's into a queue. And when we pull that course out, that means we are able to handle this course. Then we just have update the results, right? We have create a result array. So it will be kind of straightforward. So let's write the BFS way to do the topological sorting first. So we need to create two maps. One is called integer list of integer. We call graph. So you hash map. And also another one is integrates, right? Or integrates. Because you hash map. So actually, we can copy most of the code from the course schedule 1. And we are going to import the I equals to 0, I smaller than number of courses. I plus plus, we are going to create a dummy one first. But I use array list. And so that we don't need to worry about the key. Key does not exist in degrees. But I not 0, okay. So we compose the graph for this every prerequisite in these prerequisites. In this kind of prerequisites, they have graph get prerequisite 1, right? Add prerequisite 0. And also child is 0, right? So having degrees. But is 0. And in degrees get plus 1, right? So the same thing is that we need to have a queue integer equals new array that then we try to see for every integrals, right? So for map of entry integer. Entry integrals. Well, degrees of entry sector. So let's say if entry that get value equals 0, that means this is no prerequisite, right? So we'll have to offer entry key set key, right? So the same thing will have in count, but now we are going to have result for new into number of courses. So what we're going to do is that while this queue is not empty, we pour this course out into course current because the queue of right. And we're going to have input count plus plus, and we can update this result. Result count equals current. Okay, so please do this actually. Then for each child, for every child, for each child in graph, if current. We get it to child in degree, right? In degree equals in degrees get child. And we have in degree subject I1, right? In degree equals 0. We put that into Q, right? Q that Q proper child. We also update this child's integrate map degrees. Put child in degree. Okay. So in the end, we try to see if this counts already equals the course numbers return. If this counts equals this course number, then it will be our results. Otherwise, we got to review into the okay. Entry set. Cannot stereo and T. We initialize. Let's visualize their effect. So this is a BFS way doing the topological sorting. As we know, so for topologic, for every directed graph, we can also instead of use we can also use the DFS way, right? So for DFS way, we don't need in degrees map. What we need is that let's say derivatives. We need the visited array. Visited array equals it's number of courses. So for this kind of array, it has 3 status, right? So it will be 0 will be not visited, 1 will be visited, 2 will be visited. Okay. So for this kind of DFS, right? So we'll say for a to I equals 0, I small the number of courses I plus plus. If we haven't verified I equals 0, right? DFS, right? So for this DFS, it have a return boolean, private boolean. Means whether it have a cycle or not, right? So true will be has cycle. False will be no cycle. So if there is cycle, yeah, that's something. That means we cannot finish. We'll just return new int 0, right? Otherwise, we'll return something. So return something. We can use a list of integer as a list. So new array list, right? we can pass this on to the DFS. So in the DFS, what we're going to first thing is that we need the graph, right? Of course, we don't need a in degree. Let's remove this. We need a graph, and we also need a current cost. We also need a visited array, right? And also we have a list integer result. Okay. So the same thing is that we have current visit currently equals to 1, and after we iterate of the child, we set this equals 2. So visit current equals to 1, right? And then for every child, child on the graph is current do something, right? Then we have visit current equal to 2, right? So it is trying to return true or false. True, that is a cycle. So if any of the child has a cycle graph, that means we have graph under this current related result. Then we are going to return true. So if all of the child don't have cycle, then we return false, right? So when we enter in this kind of DFS, we translate if visit current equals 2, right? Then there's no cycle, return false. And if visit current equals 1, well, return 2, right? So here, under this DFS, if there is no cycle, right, we can add current to our result list, right? So list add current. So what this one do is that we'll have the, for example, A, B goes to C, right? So in the end, we'll have A. So at the top will be the C here, right? So if there is a random pick a cost here, right? So if we have a D here, it will have pointer to A, right? So it will append this D on the end of the cost list, right? So we'll say the top one on the list will be C, right? So that is the cost we finished last, right? So this because this is direct graph that the one which pointed to. So that means the result is in a reverse order. So we just need to, for the result, we need to reverse back. So what we need to do is that we have int result plus int number of courses, and for int I equals 0 and smaller than number of courses I plus we have result I equals the list get number of courses minus 1 minus I. In the end, we just return result. Right. If DFS graph I visited and list, okay. Visited number 44. There's some visited. Cannot find symbol. Visited current visited. Int 44 and 45. result. Implicit product result. Okay, so this is a DFS way to do that question. We should also be able to do this in DFS way.